We'll come back to a little more on variable analysis, doing some quick skills that we could use for AP Physics 1. In the last video, whether or not you saw it, we can basically recap that if we have an equation that relates some important variables, we should be able to quickly tell whether those variables are inversely or directly related. And we should be able to, if we get a change in one of them, some sort of numeric change, we should be able to predict what happens to some other variable in the equation. We used fill-in-the-blank analysis for that. Now, we're going to look at some situations that are a little more involved and require a little more physics thinking to them. Just a chance to branch out and look more at what you're going to have to maybe be expected to do on the test. So we have a question here. A race car driver, a race car can drive around a turn of radius r at a certain maximum speed v. If the driver needs to go around a different curve of radius 1/2 r, what will her speed need to be? Now, we have to bring in a fair amount of background knowledge with this. We have to recognize that if she had a maximum speed of v, if she were going any faster, the friction that she had would not be enough to get around the turn. And a car going around that turn would have a free body diagram that would look something like this: force of gravity down, normal force from the track up, and we have a sideways force toward the center of the circle, and the thing that's doing that is friction. We have an unbalanced force in that direction, and so that force of friction toward the center of the circle minus, well, nothing's pushing out, equals ma. And we have to recognize, and this is the key part here, centripetal acceleration. In nowhere in the question did they tell us, hey, the important variable here is centripetal acceleration, but let's think about this real quick. Centripetal acceleration equals v squared over r, and when they brought up v and r in this discussion, that was supposed to ring a bell. And what we have to recognize is that at the maximum speed, she's getting the greatest acceleration, and if she were to go any faster, she wouldn't have enough friction and wouldn't be able to stay on the track. She would end up sliding out. Okay, so from that description, we had to arrive at, hey, we can only get so much acceleration because we only have so much force. Acceleration, in this case, equals v squared over r, the centripetal acceleration toward the center of the circle. And then what we have going on here is a little different than previous because that we need the acceleration to stay the same. So in other words, acceleration here is actually a constant. It's not a variable. What are the variables? It's v and r. And which variable are we being asked to make a claim about? We're being asked to make a claim about the variable v. So what do? Well, if I'm being asked, if my key unknown, in other words, is this variable and the other variable is still on the same side, let's get that key unknown. It's just always a good idea to get it alone. So if I do that, I'm going to have to multiply the r to both sides, and then I'm going to have to square root. A lot of people forget that that square root goes in there. So my starting equation, and the key equation here, v squared over r, a lot of you guys probably jumped to that right away, but we had to rearrange it to get the key unknown alone. So once I have this new equation that is set in the perspective that I want, we're being asked to predict what happens to v when r changes. Well, are they direct or inverse? And what happened here? R went down. Well, r and v, they're both in the numerator, and they're both across from each other. So we can say that they are directly related. They're directly related, and r went down. So v goes down. So that was the key part. I had to rearrange the equation to get my key unknown alone. And then I evaluate, hey, is that variable, was it directly or inversely? Oh, it was directly related. What happened to that variable? My variable, my radius, went down. So since my radius went down, my velocity now also will go down. It'll be less than v. Now let's figure out what we're going to do to get specifics. So in fact, we can change the question around not just to say, is it less than or greater than, but let's use the equation that we came up with. And we can now make a better prediction beyond just saying it goes up or it goes down. What will our speed need to be if we have 1/2 r and the same acceleration? Now again, that acceleration is the same because we want to keep the same force. All right, well, I have square root of 1/2 times square root of 1, and when I put this in my calculator, we get about 0.709. In other words, our new velocity will be about 0.709 times the original. And so that's not less than 1/2 v. It is not exactly 1/2 v. It is between 1/2 v and v. All right, so we had a little more going on there. We had to bring more physics background knowledge and do a little rearranging of our equation. But the key points still came down to, once we had that equation, evaluate, was that a direct or inverse relationship? And then we could use our fill-in-the-blank analysis to make an actual numeric prediction of what would happen to our variable. Thanks, come back for the next one and we'll talk about gravitation.